And we're live. Action. Hello everyone. Eric Kiswa here again with another video in our Project Moongate series. In this episode, we're going to be covering processing input, or at least one way to process input, which may or may not change down the road. That little asterisk that I'll have to put everywhere. At any rate, this is where we left off in our last video. As you can remember, we've got our basic rectangle drawing using the SDL2 rendering API. So let's go ahead and escape out of that one. Okay. So what I'm thinking of for handling input is I want to do a queue system using the standard template library DQ. And basically what I want to do is if our engine, if you recall in our engine CPP, we've got a few bottom level, what I'm calling bottom level key handling. So for example here, if at a bottom level, for the moment, at the bottom level, if we detect the escape key in our event queue, then we shut down the application. Maybe in the future we'll want to change this to, you know, displaying a main menu, or at least some kind of menu for the user to either quit or go back to the main menu. I don't know, whatever. Lots of games handle the escape key differently. So, and at some point we may move this out of the base handling in engine and just keep shoveling it right up into the app. So what I want to do here is create a basic, use the STL library. Oops, sometimes Visual Studio Code will do that. DQ, and we'll just put key queue, or queue keys. How about that? That's nice and generic. Queue keys. Okay. And then what we'll do is, first of all, we're going to need in moongate.h, let's go ahead and add, let's just add string in general, and then let's maybe add DQ for what we want to use here. And then so an engine, okay, so we've got our DQ STL container, which will just be which will be filled with our keys. So basically what my idea is that at the beginning of every loop, every frame processing, we clear our queue of any STL events which have captured keystrokes. So we clear those out. And if we don't process any here, like if we don't handle any here within our main core engine processing, then we throw them into the event queue. So let's just switch. Okay, so we detected an SDL2 key down event type, and we go through and process the ones that we want to handle within our engine. And so for the moment, as I mentioned before, we're only handling SDLK escape, which is the escape key. So let's add another default, or let's add a default handler. And what we're going to do is queue. That's a really weird name. I'm sorry. I'll find a better variable name later on. Pushback, and then we want to push back the event. And we'll just add a break. Oh, it's probably not needed, but let's add one anyway. Okay, so by default, if we don't handle any of the keys in our handler here, then it will just get stored into our keyboard STL DQ handler, or DQ structure, sorry. Okay, and then what we want to do is let's pass it into our update method. So let's queue keys, which will then complain because of course we haven't defined it anywhere. So in our world.h, in the update method, let's go ahead and update the parameters into our world declaration to handle an STL event, an STLDQ structure containing STL events. Sorry, that's a lot of ST things to string together. Okay, so we've got it in our update, and let's go ahead and add that into our let's update our world declaration here, and let's go ahead and add it into our snake world update, and snake world update there. Okay, so for now we're just going to call it queue. Okay, so far we've got our queue, our queue of keys. Oh, terrible. So now what we're going to do is within our snake world update function, we're going to go through our DQ and handle any keyboard events that we're getting into our actual snake world state. So let's create a for loop of our events. Okay, oops. So what we want to do is, now this is where we handle things like, you know, up, left, down, right for directional keys, or WASD, WASD, etc. So let's do a switch of key event, oops, .key.keySim.sim. And that's kind of the long reference to the actual name of our key. So let's say for SDLK up, we've got something that we want to do when we hit up, and something we want to do when we hit down, something we want to do when we hit the left arrow key, and something we want to do when we hit the right arrow key. Okay. So in the future, we're going to be adding sort of entities to support. That might even actually have to be the next video, is some entity support within our Project Moongate, within our Moongate library. But for now, we're going to have in the snake world object, I'm going to just create a two private variables, x position, let's just call it _x and _y. Okay, and then what we're going to do in our snake world constructor, okay, so _x will be equal to 200 and _y will be 150. Let's try something random like that, maybe 200. And then what we're going to do is let's see how this is going to work. Okay, so if we hit the up key, then we are going to increase y equals _y plus, I don't know, let's say 5 pixels. So this is going to be just 5, something like that. And then down, I always get the directions kind of screwed up, so I bet you we may even have to -5. And then left, let's do the same thing. So x, across the x-axis, we want to go left, so we want to go -5. And if we're hitting the right key, then we want to increase our x-axis variable, so x _x plus 5. Okay, and then in our render method, all we need to do is position our, instead of positioning our rect at 250 and 150, we want to position it at _x and _y. Whoops, _y. So let's go ahead and rebuild everything. And okay, let's rebuild snake there. Let's run it. So we should see our rectangle. Now if we hit the up arrow key, we go down, which is the direction I always get screwed up on the Y. And so let's fix that now before we go into any more demo. Okay, so Y, it should be Y -5 and Y +5. And let's try this again. So if we hit the up key, we go up. If we hit the right arrow key, we're moving right by 5 pixels a turn. And if we hit the left key, we're going left. And down key, we're going down. Cool. That's pretty rad, eh? Okay, so what I quickly went through is that I'm using a queue structure because STL handles things in a queue system. No, that doesn't sound right. STL works as an event-based message system at the core of it, right? Which is how most modern operating systems process anything that's happening, in the operating system. Is any action that the user is taking, such as you're moving your mouse, or you're opening or closing a program, or you're hitting the maximize button on the window, that sends an event message, which the core engine will then pick up in a listing, like a queue list. So the order of events that you send, that you're doing things, is basically the order that is getting processed by the core operating system. Now there's a few, there's some events that are more important than others. So sometimes things kind of get out of order in terms of your expectations of your actions and what gets processed or handled on the operating system level. But we don't need to go too many details into that. What I'm trying to communicate is when we push anything on the keyboard, then those key presses will be sent and processed by STL in the same order that we send them in. And we don't want to lose any of the keys, right? So if there's two methods of capturing input on keyboards or the mice in video games on the computer, and that's usually involving capturing the state of the keyboard or listening for keyboard events. So capturing the state of the keyboard is where the operating system takes like a snapshot of that millisecond time of the state of the keys on the keyboard. And then, whereas the event method, which is what we're using now in STL2, what we're using this way, is that keys that you push down just send messages to the STL2 main queue, which the poll event structure, which we then go through and process with our input handler. So the difference there is that I find if you use the polling event method, so the event-based messaging approach, you're not going to lose keys if something else interrupts the STL application, the STL game. So if you're using that first keyboard input mechanism that I was mentioning before about taking a snapshot of the current state of the keyboard, that usually works, and that's how it used to work for DOS-based games. But if any other event being generated in the operating system these days interrupts what's going on in your application, then it's possible for keys that you've pushed to be dropped, to be lost. So, imagine you're hitting left in a game and it's not responding. Sometimes it's not responding. Like you'll start moving left and then sometimes it'll just stop responding. So using this event queue approach is, I'm hoping, a better method of just making sure that any keys that the user wants to use for the game is getting captured and you can process them. So this is why I've decided to use an STL DQ structure to contain those keyboard presses. Okay, so we've added that support into the engine, and that's really basically all we need to do going forward. So now every state that inherits from Moongate World, will now automatically get the queue of our STL events, which contain our key presses. So we can handle the mouse events the same way, but we're not going to do that in this video. For now, we'll just keep it at key presses. Okay. So we've got our we've got our handling right now. Another important aspect is the let's start the screen. So in STL2, when you're drawing something, when you're using their API to draw anything, then the coordinates matter of what you're trying to work with, of course. So the upper left of your window, this is the point of origin for your screen that you're working on, or for basically your canvas that STL lets you draw to. So coordinate 0, 0 will be on your top left side, and then over in your far right will be coordinates, you know, y of 0 and x of your window size. So I think in our case right now we've still got 800. So this is point 800, and then down here, of course, we've got whatever your width and height is of your device. So I think we used 800 by 600. So this would be a width of 800 and a height of 600. And same thing down here. We would have an x coordinate of 0 and a y coordinate of 600. And of course that would change depending on how big you want to make your canvas. So another thing we can add, let's try this. Okay, so another thing we can add is, let's go back into our main world, or our main engine keyboard handler, and let's add support for toggling between window and full screen. Let's show you how easy that is to do in SDL2. So let's add a case, let's add a case statement for SDLK, maybe let's call it F1. So F1 toggles between window and full screen. So let's add a function call toggle windowed. Toggle full screen, how about that? Okay, so now let's go ahead in Engine and create a toggle full screen. Is that what I called it here? Toggle underscore, okay. Let's try toggle full screen. Okay. So let's go ahead and add an implementation for it. So in void engine toggle full screen. Okay, so this is all handled by SDL2 or SDL API. We'll use the SDL2 API to query everything and handle the toggling for us. So let's capture our current window flags. Window. Okay, and so then that just means the actual current state of the operating system window object that SDL2 is managing with the window object, the SDL underscore window object that we've been using. Okay, so let's first test if we are using full screen or not. So maybe is full screen equals flags and SDL window full screen. So maybe so I'm making an integer. So I'm creating a ternary operation here. So I'm testing SDL underscore window underscore full screen, which is a flag to the SDL window object. So if the current flag structure has this flag enabled, then it means we are full screen. Otherwise, we're not. Otherwise, we're just in a windowed window. Okay. So let's go back here, and so our int is full screen is going to be either true or false. So let's use the SDL set window full screen. Let's see, window and is full screen and set window input focus. Okay, so let's see if this will work. So what we want to do is we're testing, like I said before, we're testing the SDL, the current window flags of our window object. We're testing it for this property SDL window full screen. And we want to set window full screen depending on what the value of this conditional logic is. So instead of all this talking, let's just show it. Sheesh, right? Okay, so let's go ahead into Snake. Let's run it. So now what we want to do, I think we set F1. So let's hit F1. Okay, and we're back. So apparently if I switch between full screen and windowed, I crash my OBS video recording software. So I can't demonstrate what happens when you toggle between window and full screen, but so I use this as an opportunity for you to test it out yourself on your own system. So run it, hit F1, and you should be able to see toggling between window and full screen. So again, I'm not going to do it here. Oops. Okay, edit that one out. Another cool feature that I wanted to add into our Moongate engine is just the ability to hit a screen, an F1 key, and have it generate a screenshot for me of the current state of whatever's being displayed by the renderer. And I figure that this would be a great feature to add right now. We've just implemented toggling between window and full screen, and so I think we're going to add another support for another F key, another function key here in our main input handler. So let's use F2. So SDL key F2, and let's just call it capture screenshot. I don't like that name, but I can't think of anything else better right now. Like, you know, maybe toggle window display and capture display. I don't know. Naming things is hard. Okay, anyway, capture screenshot. So let's add support for it in our engine.h. Void capture screenshot. And let's go ahead in our engine.cpp file and let's add support for it. Okay, so void engine capture screenshot. So what I want to do, or what we have to do, let's talk about this before we start entering code, is I first want to get a timestamp of the current system time. Then what I want to do is generate a file name using that timestamp. So that way, if we have a whole ton of, if we want to take a whole ton of images to upload to social media, then we've got timestamps on everything to help us, figure out which ones we want to use and which ones we don't need to. So we capture the timestamp, we generate a file name using that timestamp info, and then we use some basic SDL2 renderer methods to capture a screenshot of the current state of the renderer and save that into the newly generated file, or sorry, save that into using the generated file name. Okay, so let's go ahead and let's call, let's declare some variables here, int w and int h, and this will just be the width and the height of our current renderer size. So there's a method called getRenderer output size, and we pass in our renderer, and we also pass in the address to our width and height, and it will then fill them. This function will then fill these two variables with the proper width and height of our renderer. Okay, time to use time. So I had to Google this because I barely ever use the time libraries. So basically what we want to do is, okay, first we better include time or ctime. I think that's all we need. Okay, so first what we want to do is we declare a raw time variable using the time t type, and then we declare an instance of the struct tm, and we capture the raw time. We convert that raw time into a local timestamp, and then we generate a file name that we can use. Okay. So we take our buffer, our declared buffer, which is a character buffer of maximum size 80 characters. We use the strftime function to copy into this array, character buffer array, a screenshot, like a file name of screenshot, the year, the month, the day, an underscore, and then an hour, minute, second, and then bitmap. Uh-oh, gonna sneeze. Okay, I'm not gonna sneeze. Okay, so we've generated that. This is the name that we're gonna use for our file name, for our bitmap file name. Then what we're gonna use is we're gonna use some SDL methods to take care of everything for us. So what we're going to do is we're going to create a temporary SDL surface, which is a video surface a surface area in your video memory of your video card. We're going to use a method called create RGB surface to create this, and we're going to give it the width and height that we took earlier on right here in get render output size. We're going to keep a depth of 32. I wonder if I need to capture that somehow. That might be a potential bug, but whatever. And so we don't want to create an input mask at all. So we can just leave these as default numbers. I wonder if we even need that to create it. Okay, anyway. Then we use a method called SDL render read pixels. And so what this will do is we pass in the renderer, and this will take a pixel format, again, whatever. It's not really important right now to go through that, but we want to pass in the pixels that we've captured from our surface, from our created surface in video memory, as well as the pitch, which is the depth, the depth of that video depth of that buffer. Again, I don't know if it's worth going into what video depth really means right now. But anyway, we're passing in the properties of the preserved or the newly created temporary hardware surface in video memory. And then what we're doing is we're calling an SDL method called saveBMP. So we're creating a new BMP file, taking this screenshot, temporary video hardware surface buffer, and using the file name that we generated right up here. And then to finally clean everything up, we're just going to be using free surface to free this chunk of memory that we allocated to work with the hardware video surface. Okay, that was a lot of talking and explaining. Let's see this in action. So we've got this going to F2, I believe. So before we do that, let's clear our background. I really like the cornflower blue, but let's just clear it to black. So let's set render, draw color of renderer. Okay, so we're going to clear it to black. We're going to show our white rectangle. You know what? Let's make it red, just to really prove that we're changing things up here. Okay, so back in Snake World, when we come down here to the renderer, let's change this method here. So now we should see a red, and we're going to use fill rect to draw a filled rectangle. Okay, so let's test this out. And we should see, okay, so black background with our red square that we can still move around with our keyboard. Okay, and then hit F. Let's see, was it F2? So hit F2, and it should generate a screenshot for us. So let's hit escape. And we should use like a log message or something to basically, you know, tell you that this happened. And let's go into our project folder. Snake. Oh, there it is. Okay, so in our snake folder, in our snake project folder, you can now see that we've got a screenshot with the year, month, day, and the hour, minute, and the second. So let's go ahead and open that up. And we have our screen background of black with our red square. All right, that's pretty cool. So I am just going to put in a log message. When we generate a screenshot, just so that we have something to follow. Okay, so let's create one here, an SDL log, and let's say engine toggle full screen, and then we'll add another log entry for just before taking the screenshot. Engine capture screenshot. Cool. Well, that was a lot of fun, everyone. We got in keyboard event presses today, and we updated a few of our core engine functionality to support window full screen toggling, as well as an easy way to capture the screenshot of the current renderer, which I think is pretty handy for when you want to show your friends, show your family, show anyone on Instagram or Twitter what you've been up to, and makes it easy to share projects that you're developing and working on. Okay, well, that's about it for today's episode. If you like what you saw, please give the video a like and follow the channel. Leave a comment for the video if there's anything that you really want me to go through again. Sometimes my English, I just flub up explanations. So if there's something that you'd like re-explained, hey, no problem. Just leave a comment, and either I can explain in the comments or just make a new video on it to try and help everyone else out. Hope you have a good day, and we'll see you next time. Peace.